Today we're going to look at lessons 8.3 and 8.4, which these are all about multiplying binomials and special cases. So our objective today, we're going to multiply two binomials. So first, let's recall multiplying a monomial and a binomial together. So remember, a monomial is one term. A binomial is two terms. If I'm multiplying a binomial and a monomial, the monomial is essentially going to be getting distributed to everything that's in the parentheses. So since 2x squared is outside, I'm multiplying that by the 3x to the fourth. So the 2 and the 3 get multiplied together. Well, 2 times 3 is 6. And then because there's an x on the outside and there's an x on the inside, they're being multiplied. So I keep the base and I'm adding the exponents. So 2 plus 4 is 6. I'm going to bring down that subtraction sign, and now I'm going to repeat. The 2x squared is getting multiplied by 10. So 2 times 10 is 20. Because there were no variables with the x, but there is a variable that I'm distributing, that means I'm keeping the variable as it is. So the x squared is just going to move over with the 20. Because these are not like terms, because the x to the sixth is different than the x squared, and because the 6 for the exponent is bigger than the 2 for the exponent, it's in standard form. This would be my answer. All right, so it was important that we remembered how to distribute, because today we're actually going to be looking at two different methods in order to multiply binomials together, or eventually a binomial and a trinomial. So let's talk about the two different methods. The first method is called the distributive method. So that's why I wanted to practice distributing. When we're talking about the distributive method, essentially what we're going to do is we are going to break up the first polynomial and distribute each term to the second polynomial. Okay, so we'll break up the first polynomial and distribute each of those terms to the second polynomial. So what does that mean? Well, if we look at this first problem where it says x squared it just says x plus 3 times x plus 4. I know it's being multiplied because in between those two parentheses, I don't see anything. So that means that those two are being multiplied together. So like this distributive method says, I'm going to be taking this first polynomial, which in this case is a binomial, and I'm going to break it up. And essentially then the second polynomial, I'm going to end up keeping that the same. So what I mean is that if I'm breaking up the x and the positive 3, I'm going to start with the first part, which is x. That x has to get distributed to the polynomial that I'm keeping. So it's going to get distributed to the x plus 4. Then I'm going to go back to where I'm breaking up my polynomial. I have a positive 3. And that is also going to then get distributed to what I'm keeping, which is the x plus 4. So whatever I'm keeping, I'm going to be writing multiple times. Whatever I'm breaking apart turns into the monomials that go out in front of what I'm keeping. So now that I've broken this up, it's just like what we reviewed. I'm going to distribute the x to everything in the first parentheses. So x times x means I keep the x and I'm adding the exponents. Technically, each of these have an exponent of 1, so 1 plus 1 give us 2. Then x gets multiplied by 4. Well, x times 4 is 4x. Then I'm going to take the positive 3 and I'm going to distribute that to everything in parentheses. Well, positive 3 times x is a positive 3x, and then positive 3 times positive 4 is positive 12. I see that I have a couple of like terms, so I am going to combine those, and I want my final answer in standard form, so biggest exponent down to the smallest. X squared is the biggest, so that will stay. 4x plus 3x is going to give us 7x, and then we'll still have that 12. So x squared plus 7x plus 12 would be my answer. Okay, if we take a look at this next example, x plus 5 times x minus 2. So remember, I'm going to break up the first polynomial, and I'm going to be keeping the second polynomial. So if I break up the x plus 5, I'm going to start with the x, distribute that to what I'm keeping, which is x minus 2. Then I go back to what I'm breaking up, so the positive 5, which also has to get distributed to what I'm keeping, which is the x minus 2. So start distributing. X times x will always give us x squared. X times negative 2 is negative 2x. Distribute the 5 to everything. 5 times x is a positive 5x. 5 times negative 2 is negative 10. Once again, I see that there are several like terms. I'm going to combine those, write my answer in standard form. So x squared negative 2x plus 5x gives us a positive 3x. Remember, when I'm combining like terms, just like in the last problem, I don't add exponents there. So those x's stay an x. And then I still have minus 10. And this is my answer. Okay, last example, looking at the distributive method, I'm going to break up this first one. And I'm going to keep the second one the same. So when I'm breaking up the 2x plus 7, I'll start with the 2x. That gets distributed to what I'm keeping, which is the x minus 1. Go back to what I've broken up, which is the positive 7, which then gets distributed to what I'm keeping, which is x minus 1. So I'm going to distribute the 2x to those two terms. So 2x times x is 2x squared. 2x times negative 1 is negative 2x. Then I'm going to distribute that positive 7. So 7 times x is a positive 7x, and 7 times negative 1 is negative 7. We've got a couple of like terms. Writing it in standard form, I'll keep the 2x squared first, negative 2x squared first. Negative 2x plus 7x is going to give us a positive 5x, and then we'll still have minus 7. And there is my answer. Okay, so that's the distributive method. Now let's go ahead and take a look at the table method, which I really refer to as the box method. Okay, so essentially with this box method, we're going to be creating boxes. So to create our boxes, we multiply the amount of terms in each polynomial. Okay, so to create our boxes, we multiply the amount of terms in each polynomial. So let me explain what I mean by looking at these examples. So in this first example, I've got x plus 4 times 2x plus 3. So it looks like this first polynomial is a binomial. There are two terms. In the second polynomial, I see another binomial. I see two terms. So that means I'm going to be multiplying 2 times 2 to tell me how many boxes I need to draw. Well, 2 times 2 is 4. So I'm going to create 4 boxes. Okay, so I'm going to create a box where then I'm breaking it up into fourths because I want 4 boxes. Okay, I'm going to be putting each of these binomials on 2 out of the 4 sides of these boxes. Now, I usually always put it on the top and on the left. Okay, it does not matter which one of those binomials you put on the top and which one you put on the left. I'm going to put the x plus 4 on the top. So I always am going to be breaking up my boxes with addition signs, regardless if I see addition or subtraction inside of the parentheses. So I'm going to start with the x plus 4 on the top. I'm going to put the x first. Luckily for us, there is a positive sign, and then I'm going to put the 4 with the other box. So that means that on the left, I'm going to put the second polynomial, which is 2x plus 3. So I'm going to put the 2x for the first box. Luckily for us, we have an addition sign, so I get to keep that addition sign, and then I'm going to put the 3 in the second box. Okay, so what we're going to do is we are going to multiply the terms on the outside to fill the boxes on the inside. So I'm going to start with this top left box. I've got 2x on one side and I've got an x on the other. So I want to multiply those together. 2x times x, and I'm going to fill it in with the box, is 2x squared. The top right box has one side, which is 4, and then technically the other side is 2x. So 4 times 2x is going to fill in this top right box. Well, 2x times 4 is 8x. Now I move on to the bottom boxes. So the bottom left, one side is a 3, and one side is an x. 3 times x is 3x. This last box here, one side is 4, one side is 3. We're going to multiply those together. 4 times 3 is 12. Notice that anything that is like terms in my box, I'm going to be combining. So I see a squared term, an x, and a 12. So it looks like I've got 2 x's that I want to combine. Otherwise, I'm going to put everything in standard form. So I'm going to start with a 2x squared. I'm going to combine my like terms. So 8x plus 3x is going to give us a positive 11x. And then that 12 is also positive, so plus 12. And here is my answer. If we look at the next problem, I see 2x plus 1 times x minus 1. So I want to count up to find out how many boxes. It's a binomial, so that's 2 terms. Here's another binomial, that's 2 terms. So once again, 2 times 2, I want 4 boxes. So anytime it's a binomial times a binomial, we will have 4 boxes. So I'm going to create my 4 boxes. I always want addition signs breaking up my terms. So I'm going to put those first, and then I'm going to look at my binomials. So once again, I'm just going to put the first binomial on the top. So 2x plus 1, I'm going to put the 2x first. The plus sign is going to stay as it is, and then I'm going to put the 1 in the second box. That means that the x minus 1 is going to go on the side. So I put the x first. Notice that I see a subtraction sign. I'm going to keep that negative sign with the 1 because I need to have an addition sign breaking it up. So that means the negative goes with the 1 down here in this other box. Now I can start multiplying to fill in the boxes. So we have an x on one side. We have a 2x on the top. That's going to fill in this top left box. Well, x times 2x is 2x squared. Then if I want to fill in the top right, I've got one side is 1, one side is x. 1 times x is 1x. When I fill in the bottom left, one box has a negative 1 for a side and a 2x for the top. So 2x times negative 1 is negative 2x. This bottom box, one side is 1, one side is negative 1. 1 times negative 1 is negative 1. Notice that I've got a couple of like terms, so I'm going to combine those. Everything else, though, I'm going to just rewrite so I can put it in standard form. So I'll have to start with the 2x squared. If I combine those like terms, 1x and a negative 2x is going to give me a negative 1x, and then I'll still have minus 1. And this would be my answer. All right. Last example, notice that we've got a binomial and a binomial. So binomial times a binomial, 2 times 2 tells us I'm going to have 4 boxes. So I'm going to make my 4 boxes here, which always is going to be broken up with addition signs. Okay, the x plus 4 is first. I'm going to put that on the top. X plus 2 is second. I'm going to put that on the side. Filling in the boxes, I multiply. X times x will give me an x squared. X times 4 is 4x. In the bottom, 2 times x is 2x. And 2 times 4 is 8. Once again, I see that there are several like terms for me to combine. Writing it in standard form, x squared will go first. Combining my x's, 4x and 2x gives us a positive 6x. And then that 8 is positive as well. And there is my answer.